Hi, I'm Dan, and today we're going to be talking about the future value of money. This is going to be the start of a series of lectures, presentations regarding the future value of money. So, what is the future? What is the formula for the future value of money? The future value equals the principal, the amount invested, times 1 plus the annual rate, the annual interest rate is expressed as a nominal form, as a decimal form, divided by the number of times the interest is compounded per year, to close parentheses, to the exponent, the number of times the interest is compounded per year, times the number of years the money is invested. So what is the future value of $50,000 with an annual interest rate of 5% compounding monthly for 10 years? Well, that would be the future value equals $50,000, the amount invested, times, and this is in parentheses, 1 plus the nominal interest rate, which is 5%, so it would be expressed as 0.05, divided by 12, which is the number of times the interest is compounded per yearly. The close parentheses, and that's to the exponent of the number of times the interest is compounded yearly, times the number of years that the investment will last. So it's 12 times 10. So then the next line, when you divide 0.05 and by 12, you get this number here, 0.004. And then when you add the 1 to that and make the exponent to the 120th power, you get this number, 1.647 and change, times the principal, which then gives you your answer, which is $82,350.05. So what if, though, the interest is only compounded yearly, once a year? And the same thing was, you invested $50,000 at 5% for 10 years, interest compounding yearly. Well, you follow the same formula, which is 50,000 times, in parentheses, 1.005, which is the nominal interest rate, divided by 1, because it's only going to compounding, the interest is only be compounding once per year, so that number is only only 1, and then to the exponent 1, the number of times the interest is compounding per year, times 10, representing the 10 years that the investment lasts. So then when you divide 0.05 divided by 1 is obviously 0.05, and 10 times 1 is obviously 10, so that's why we get this line right here. And then the next line is 50,000 times the result of this, which is 1.6288 and change, and you get your result of $81,444.73. What's the difference? The difference is $905.32 between the same amount of money, $50,000, earning the same interest rate, 5%, over the same period of time, which is 10 years, except the difference is one is compounding monthly and the other is only compounding yearly. And the one that is compounding monthly will produce $905.32 more.